Hello, the topic of this presentation is component compositions of mixtures of cement wood heat insulating material. The volume of timber procurement in Russia is approximately 200 million cubic meters per year. At the same time, waste from wood processing is about 32% of the initial material. Most of it is sawdust, shavings, and chipped wood. At the same time, most of it is stored at landfills or burned, which is economically unprofitable both for enterprises related to woodworking and for the national economy. Up to 21% of woodworking waste is used in the production of building materials such as abolite, cement-bonded particle boards, wood particle boards. At the same time, substances that are used in the production of these materials, such as phenol, formaldehyde, resins, reduce environmental friendliness and sometimes pose a danger to human health. In this paper, it is proposed to use wood shavings in the manufacture of cement composite heat insulating materials, which can be used, for example, in three-layer monolithic structures with a heat insulating layer of wood cement material. It is assumed that there is a possibility of obtaining a relatively cheap, environmentally friendly, high-quality material. Its main advantages can be the availability of components and an uncomplicated production process in comparison with other heat-insulating materials. One of the most important physical and mechanical properties of a cement heat-insulating material is the coefficient of thermal conductivity. There are detailed studies of the dependence of this property on the size of wood filler particles. However, there is insufficient information on the strength of the samples under study and the component compositions. The aim of the study is to select the ratio of the components of mixtures of cement heat insulating materials using wood shavings. The thermal conductivity coefficient is taken as the objective function considered in the study. The process of obtaining cement-based heat-insulating materials with desired properties can be conditionally divided into two main stages: determining the regularities of the influence of various factors on the physical and mechanical properties of the material, and determining the composition and production technology of the material with the required properties. Portland cement was used as a binder in the design of the compositions of mixtures of cement heat insulating materials. The filler was fine quartz sand and woodworking waste, spruce shavings. Also, slaked lime was used as an additive to neutralize the simplest sugars in wood, such as sucrose, glucose. Due to the heterogeneity of the components included in the mixture, traditional mixing methods did not give the desired result, so the components were dispersed in a vibrorotary mill of periodic action. The technological mixing mode was determined during preliminary studies. The process of changing the physical and mechanical properties of a composite building material proceeds under the influence of various factors, the nature of the influence of which is difficult to describe. The use of experiment planning in the study of the physical and mechanical properties of a composite building material presupposes purposeful control of the course of the experiment, which is implemented under conditions of an incomplete understanding of the mechanism of change in physical and mechanical properties depending on a number of factors. This approach makes it possible to implement the main planning principle, obtaining the required accuracy of the mathematical description with a limited number of experiments. Based on the analysis of preliminary information, the factors that most significantly affect the physical and mechanical properties of the cement heat-insulating material are identified. When planning the experiment, the following intervals of variation of factors were considered. The choice of the number of levels of variation was determined by the curvilinear nature of the dependence of the physical and mechanical properties of the cement heat-insulating building material on these factors. The choice of the factor space was made taking into account the interpolation capabilities of the constructed model according to the following plan. It was assumed that the dependence of the physical and mechanical properties of cement heat-insulating materials with the use of woodworking industry waste can be described by a reduced polynomial of incomplete third order, the coefficients of which depend on the values of the factor levels. Samples with 25 different compositions were prepared for the experiment. The number of samples in the experiment, 3 duplicate samples were prepared. When testing for central compression, density and thermal conductivity was 75 cubes. Based on the results of tests for compressive strength, density and thermal conductivity for each property, a mathematical model was obtained that describes its dependence on all the above factors. For clarity of the data obtained, surfaces were constructed with 2 fixed values of the factors and 2 changing ones. The graphs show the following regularities. The strength of the material increases from 0.4 to 2.8 with a decrease in the waste-cement ratio and an increase in water-cement ratio. Since the introduction of wood waste into the mixture increases its water demand and porosity, the thermal conductivity coefficient decreases from 0.38 to 0.19, with an increase in waste-cement ratio and a decrease in water-cement ratio. One of the significant factors affecting strength in the water-cement ratio, the effect of which on the change in physical and mechanical properties with a quartz sand villa and with different waste-cement ratios is significantly different. The strength of the samples with an increase in the water-cement ratio from 2 to 3 increased on average by 25%. With an increase in the waste-cement ratio from 0.25 to 0.75, the strength, on the contrary, decreases on average by 64%. With an increase in the sand-cement ratio varying from 1 to 2, a decrease in strength was observed on average by 30%. The coefficient of thermal conductivity of the samples with a change in the water-cement ratio from 2 to 3 increases by an average of 30%, with an increase in the waste-cement ratio from 0.25 to 0.75. On the contrary, a decrease in the thermal conductivity coefficient by an average of 15% is observed, since with the introduction of a large amount of sawdust, lighter and more porous materials are obtained. Analyzing the resulting graphic material, it is possible to determine the compositions of cement heat-insulating materials with predetermined physical and mechanical properties. When using this technique, several compositions of mixtures of cement heat-insulating materials were selected with a coefficient of thermal conductivity 0.25 and 0.3. By changing the ratio of the components in the mixture, it is possible to achieve a significant change in strength from 0.7 to 1.8, mixtures number 6 and number 8, or to change the ratio of the components with practically unchanged properties of the material, mixtures number 2 and number 3. Using the obtained compositions, it is possible to manufacture building products with the required properties. The final composition of the mixture is selected based on the physical and technical requirements and technical and economic ones. Fields of application of the obtained products for filling in partitions and separation walls, small wall blocks in low-rise construction, subject to protection from external atmospheric influences, partition blocks, thermal insulation of floors of the ground floor. On the basis of the experiments carried out and the study of the physical and mechanical properties of cement materials using wood waste, the possibility of using sawdust as a filler in an amount of 0.25 to 0.75% of the binder mass under special technological conditions for preparing a mixture, selected dispersion parameters in vibrorotary mill of periodic action is proven. As expected, with an increase in the sawdust content in the mixture, waste-cement ratio in the range from 0.25 to 0.75, the strength of the sample significantly decreases up to 64%, and with an increase in the water-cement ratio from 2 to 3, it increases by an average of 25%. The coefficient of thermal conductivity of the samples increases to 30% with an increase in the water-cement ratio from 2 to 3, with an increase in the waste-cement ratio from 2 to 5, from 0.25 to 0.75. A decrease in the thermal conductivity coefficient by an average of 15% is observed. For the practical use of the research results, the compositions of mixtures of cement heat-insulating materials with predetermined values of the thermal conductivity coefficient have been determined. Thanks for your attention.